So we are going to go through kinematics important concepts which some people might not have heard of or done of in class, which are totally J advanced oriented. So let's say you have a projectile like this. So, and obviously there's an acceleration g downwards. Now this thing where you can write, let's say, a particle at this time, like it's thrown from here, right? So you can write a vector s, displacement vector, a u vector t, and a half g vector t square. See now, the concept for the u vector t is, imagine we throw a particle and there's no acceleration. How far will it go in time t? That's ut. Now, for the concept of half gt square, let's say a particle is there and it's free falling. So that gives the distance over there and s. So you can also write this in the vector format: ut plus half g vector t square. This is very important, okay, for solving questions. Okay, now let's look at a question, for example, where we can use this, right? And in this question also there will be a very important concept which can directly give you the answer for many J advanced type questions. So let's say it's a platform H1, H2, so this distance is D, right? So now we want to convert like in this type of format, and the question is asking also find u min for it to touch these 2 points, right? First of all, you can draw the diagram like this: h1, h2, and this as h1 minus h2, and there's a projectile, and obviously wait, this is D. There's a projectile like this over here. Again, now if we do the vectors, we did the first little be u t, right? First one, this from the ground was a v0. Let's take this as u, right? And now there's a velocity falling here as half, not velocity, the other vector, which is half gt square, right? So let's take this angle as alpha. Now, using sine rule, we can write ut by sine alpha is equal to d sine theta equal to half g t square sine alpha minus theta. You can resolve all the alpha theta angle and you write sine law like this. I already have the result, so I did it directly. Now if we square this, ut by sine alpha whole square is equal to d sine theta into half g t square sine alpha minus theta. You get u square equal to gd sine square alpha by cos 2 theta minus alpha minus cos alpha. Now for minimum, as you can see from here, we write theta equal to alpha by 2. Okay. As you can say, it's an angle bisector. So this is a very important case. You can write for a required U minimum with a given D, we take it along the angular bisector. Okay. Now let's look at different type of question. Okay. Oh yeah, by the way, this is angle theta. Okay. Now this also works for range to be max. The object should be thrown along the angle bisector. Even for a normal projectile, if you check it, if it's thrown at an angle 45 degrees, range is max, right? It's the same way if you do it from any point. If you want range to be max, you take it along the angle bisector. Or when there's given D and you need a velocity V minimum for that, then again you take angle bisector. Now, let's see one more thing. There's one more important observation. For range to be max, final and initial velocity vectors are perpendicular. Okay. Let's take an example. Let's say you're throwing a particle. This, let's say, is alpha. So some theta or something, and you want range to be maximum. So there's some velocity v2 vector. There's a g vector here. So we can write a vector form like this: u vector. Finally, there's a v vector. There's a half gt. Wait, no, sorry. V equal to u plus at. So it's gt. So if we write all the angles, this is alpha, this is pi by 2 minus alpha. So v is equal to u plus tg. Now if you do v dot u, you get a u vector plus tg vector, or u vector, which is u square plus tg u minus cos alpha. U square minus 2 u sine alpha g cos theta g u cos alpha. Now we will get u square 1 minus sine 2 alpha by cos theta. Now for range to be maximum, it lies along the angle bisector, so this is 1, so you get 0. Dot product is 0 means perpendicular vectors, so u and v are perpendicular. That was this important. Another concept. Let's say let's say this is moving with an a naught, and this is some a we have to find. So the dumbbell is initially at rest on the upper end. Is suddenly provided with an acceleration a naught as shown. The lower end will move how much? Okay, I guess that can answer the same. So we just do it along the components, which is a naught along the component of the dumbbell. A naught cos theta is equal to a sine theta. So a is equal to a naught cos theta. Okay. Now we'll check the next concept, which is distance of closest approach. A ship A is sailing towards the northeast velocity. Okay, so the ship A is sailing with velocity 30 I cap and 50 J cap. A ship B is at a distance of 80 km per hour east and 150 km north. So this is the coordinate, and it's moving west with this 10 km. So if we go to the frame of B, we sit on B, then we give this 0 velocity and we reverse the direction of velocity of B and give it to A. So A will now have 50, 40. Now I'll just change here 40, and now it will move along this. Now the perpendicular distance of this D is the D distance. Now you can just take theta, and now this is alpha, this whole thing. Alpha you can do with the positions, theta you can do with whatever is given, the velocities. Yeah, that's enough. You can find it's pretty lengthy, but it gets the thing done. Next concept is the radius of curvature. Which is given as V by A perpendicular square. This also has a formula as 1 plus dy by dx whole square 3 by 2 d double derivative dx. Equation of trajectory is also important. Y equal to x tan theta minus gx square 2u square cos square theta. You can also write as x tan theta 1 minus x by r. Relative projectile, right? Let's say something flying away, something flying with you, theta 1, theta 2. It is all this into complex, so it's v sine theta 1, v cos theta 1, u cos theta 2, u sine theta 2. Now, if we want to find time of collision of v with u, what we can do is we can make u stationary. So we give the velocity as v sine theta 1 minus u sine theta 2. This is v cos theta 1 minus u cos theta 2. Now, this part will still rest. This component is the one which will be approaching. And let's say there's a distance d between them. So time is equal to distance by speed, which is that's v naught. So v naught. Okay. This concept is Fermat's principle, which says that light travels at least time taking path. So we'll look at a question. It's like there's a car which moves at speed v here, and you have to get to a point here, b. Okay. This and speed over here is v by eta, and the angles here is 90, and it's like theta. This is some x, this is some d. So if you think of light, what would light do? It would take the question asks minimum distance, right? Path, minimum distance path, fine. Yeah, I think they find minimum distance path. So yeah, we can just use light. So Snell's law. So v sine 9t equal to v by eta sine theta. So sorry, this is 1 by v and this is 1 by v by r. Sin theta, it's mu1 sin maybe I got confused. Sorry, so it's like mu1 sin is equal to mu2 sin theta. Okay. Next is chasing problems. So I think I'll take this in another lecture because it's a bit lengthy. Yeah, that's it for now. See you.